This is the NEET 2020 question in electric charges, electric potential and capacitance. This problem is on capacitors. The problem says a parallel plate capacitor having a cross-sectional area A, separation D, has air in between them plates. Okay, let's now talk about this part of the problem first. He is saying that there is a case 1. There is a parallel plate capacitor. Parallel plate capacitor means it has two plates. Each plate has an area of cross section A, that is this area where charge is stored. Distance between the plates is D and the air is the medium between them. So the capacity of the capacitor C could be written like epsilon naught A by D, that is the case 1. Now what he is saying is an insulating slab of same area but thickness D by 2 inserted between the plates having a dielectric constant 4. Ratio of new capacitance to original capacitance. Original capacitance anyway I know. I need to calculate the new capacitance. So let me write the case 2. Case 2 is the same parallel plate capacitor, but half of the thickness is filled with a material. This part is filled with a material whose dielectric constant K equal to 4. That's not air, that's a medium. The other half is air itself. So it has an air for a distance of D by 2 and a dielectric constant for a distance of another D by 2. Area of cross section remains the same. Now you can see this behaves like a combination of two capacitors, C1 and C2 in series. So what we can say is the new system behaves like combination of two capacitors in series. What is that C1 is? Let us try to write. So you can write C1 means this first part. C1 can be written like it is air, so epsilon naught A, but the distance is D by 2. C2 is, it is not air, there is a medium, so K epsilon naught A by D by 2. As these two are in series, effective capacitance 1 by C dash can be written like 1 by C1 plus 1 by C2. So 1 by C1 means, so this is 2 epsilon naught A by D. So it becomes in reciprocal 1 by C1 means D by 2 epsilon naught A plus this is K is 4 epsilon naught A, D by 2 means into 2 by D, that is 8 epsilon naught A by D, that is D by 8 epsilon naught A. So the LCM to both of them is 8 epsilon naught A. So here it is 2 epsilon naught, therefore here as it is 8, there will be getting a 4D plus D. So 1 by C dash is 5D by 8 epsilon naught A. That implies new capacitance of the system C dash is 8 epsilon naught by 5D. But I know epsilon naught A by D is original capacity C. So 8 by 5, instead of epsilon naught A by D I can write C. Now you want the ratio of new capacitance to original capacitance. So what he want in the problem is C dash by C. So what is remaining is 8 by 5. So the ratio is 8 by 5 or 8 is to 5. That's the answer for the problem. So it's a simple problem. I need to know only basic concepts to solve the problem. The concept that we need to know is capacity of a capacitor is epsilon naught A by D. Second, when a dielectric is introduced, its capacity increases by the dielectric constant times, and when it is introduced like this behaves like a capacitor C1, capacitor C2. It behaves as if like second plate of the first capacitor is connected to first plate of the second capacitor. So this behaves like a series combination, and in series effective capacitance is 1 by C equal to 1 by C1 plus 1 by C2. Knowing that basic formulas, we can calculate and find the answer as 8:5. That's how we have to solve the problem. Thank you for watching.